With this, let's take a look at the mechanics of radiometric dating and its assumptions. The typical idea of deep time presented in museums begins with a 4.5 billion year old Earth, early life forms evolving about 3.7 billion years ago, dinosaurs living between about 220 and 65 million years ago, and the human line starting to branch off several million years ago. Where did they get these ages? It's based mostly on radiometric dating, which calculates how quickly unstable atoms, such as uranium, change into stable atoms, such as lead, a decay process they believe starts when igneous rocks are formed. So, what's wrong with these methods? Well, for starters, we can't go back in time to watch these rocks form, or check the decay rates of these atoms over time. We can only observe what the decay rate is today based on laboratory studies. We don't know what the decay rate might have been in the past, or might have been under different Earth conditions. The decay rate has to be assumed, along with the starting amount of the parent element, like uranium, and the starting amount of the daughter element, like lead. We also have to assume that the dating system is closed, without contaminations impacting the outcomes. But since we can't go back in time to test these assumptions, we have to assume them to be true when radiometric dating is used. And if these major assumptions are not correct, then the ages we get from the study are also not correct. But there is a way to test the assumptions of radiometric dating. We can take rocks that were formed from a volcanic eruption, rocks that people actually watched form that are pegged to a certain time in recorded history, and then date those rocks. If the assumptions hold up, the radiometric age of those rocks should be the same as the known age of the rock, the age we can know for sure because people actually watched the rock form. If the radiometric age of the rock is the same as the known age of the rock based on when people watched it form, it would validate the assumptions in the analysis, giving credibility to the results. But did you know that these types of studies have already been done, and radiometric dating missed the known ages of rocks by millions and millions of years? Several studies have been done on rocks around the world to try to validate radiometric dating, and it fails all the time. Here is a short list. Notice that in each of these studies, the radiometric age of the rocks far exceeds the actual known ages of rocks by millions and millions of years. In fact, here is an example. In the 1980s, Mount St. Helens erupted and produced all kinds of volcanic material, including a rock called dacite that was sent in for radiometric dating. The result? This 10-year-old rock showed ages from 340,000 to 2,800,000 years, all for a rock that we know was only about 10 years old. While radiometric dating can be useful for estimating the relative ages of rocks or ash layers, like which layers were laid down first, the absolute ages will always be elusive and will typically exceed the known ages by millions of years. They can also never be verified because we cannot go back in time. The Bible is clear that God breathed creation into existence, with all the planets spiraling through the universe in perfect order to sustain life on Earth. The oxygen levels, magnetic fields, days, nights, seasons, and temperatures are all perfectly calibrated to sustain life on Earth, and it all had to be here at the same time for everything to work.